Hi guys, hope you are fine. Me too, I am fine. So guys, today we thank God for this opportunity to learn together. And so we are going to attempt these two questions. So let me start with the first one. And the first one is this. So what I'll do, I'll come here and write. I don't need to repeat it again. So what I will do guys, I'll try now to make this one fraction into partial fractions. And so I'll write like this. I'll say x all over x plus 1 x minus 1 squared like that. I now break it up into partial fractions like that guys. And so now I'll write x plus 1 here. This other one I write x minus 1, and of course I will still have another one. According to the partial fraction rules, we shall have something like that squared, so that the unknown here is a, here we have b and c. So always this one you write it 2 times to the power of whatever power it has. If it has to the power of 3, I would still have added another one, x minus 1 to the power of 3. So that's how we do it, guys. From there, guys, we come now and divide. We say here that x, this one is x squared. We say x squared is now equal to this value you divide by that. So you remain with x minus 1 squared, you multiply by a. So it will be a now multiplied by x minus 1 squared. You come to this value. This one divide by that, then you get plus b, because when you divide by that, you remain with x minus 1 of the x minus 1 and x plus 1. So this one is going to be x plus 1, x minus 1, like that. You come to this one divide by that. You remain with x plus 1, then you multiply by c. So you'll have c, then x plus 1, like that, guys. So from there, guys, we want to find out our constants. We can use coefficients, or you can also use, we set. For example, if we set x is equals to 1 here, we shall be able to finish that, so that, because that one now will be 0. Also this one will be 0. So we will remain with only this term. So let's say that setting x equal to 1, like that, then we shall have, this side we shall have 1. That is 1 times 1 is 1 equals to, this term will be 0, 1 minus 1 is 0. And this term will be 0 also, so we are left with the c there, and then 2, like that. So guys, our c now then is going to be a half. From there, guys, now we come to, we set, let's say again, setting x equals to -1. And the reason we do that, guys, is so that we can eliminate some of the constants and be left with only one constant, so that we are able to find what is the value of that constant. Guys, I will now come and put -1. If I put -1 here, this one, all of it will be 0, because -1 plus 1 is 0. If I put -1, all of this will be 0. So we are only left with this term and this term. So when we put -1 there, squared, we shall have 1. This is equals to, we put -1 here, will be -1 minus 1 will be -2. -2 squared will now be 4. So we shall have 4a. And so, guys, we shall have the value of a as being 1/4, like that. So from there, guys, we can now think about the coefficient. And the best coefficient, guys, to think about is actually x squared. For this side, the x squared coefficient, let's talk about coefficient. Of x squared. Coefficient of x squared is 1. That is on one side, on that side. In other words, we can write like that, 1x squared. So on this other side, we shall have now here we have the term a. For this one, it will be a x squared. And for this, we will have b x squared. And for this, we don't have. So we shall have 1 is equals to a plus b. Like that. And already, guys, we have a is equals to 1/4. Can convert this one into 4/4 equals now a, we have 1/4 plus b. So that now b, guys, is going to be, we can move this one this side. So we shall have 4/4 minus 1/4. And so, guys, we shall have our b equals to 3/4 equals to b. I hope, guys, you are following me up. So now we have b being 3/4. So from there, guys, we just come and fix in our equation. And this is how we fix it. We come to the equation we had there. We have a is 1/4, so we put 1/4 there, like that. Then x plus 1, like that. Then we have b, which is 3/4. That is x minus 1 there. And finally, we have c. And the c is supposed to be 1/2 plus 1/2, like that. So 1/2, this is x minus 1 squared. So, guys, we are going to have something like this. This is now what we are now supposed to integrate, guys. That one dx, we integrate that one, put dx there. We integrate that one, we put dx there. So this one, guys, is going to add up to, for this one we get 1/4 ln x plus 1. This other one we get 3/4 ln x minus 1. While this other one, guys, we shall have plus, if we move this one in the upper side, guys, for example, if we do like this, we write a half there. Let me put the integral first, but instead of putting the integral, let me use another sheet, guys, to do that. So let me use this sheet here, so that now I can write a half like that. I now put this one above, so that it will be x minus 1, and then I put -2. So if I integrate that one, guys, you'll have a half. Then this one will be now x minus 1 -2 plus 1 all over -2 plus 1. So this one will end up being a half x minus 1, this is -1, all over -1. So guys, we shall end up with negative a half like that. Then I can bring this one again down, so it will be x minus 1 raised to 1 like that. So guys, that's what I am going to write. So it will be now be minus a half x minus 1 like that. So guys, that is going to be our solution for that problem. And so guys, we continue to the last question. So that one is okay. So guys, my last question is right here. I've already done it. As you can see, it is here. And the first thing I'll do the partial fractions. And this is what I have done, guys. I have separated this one. It is one fraction. I have made it into 2. That is to make it easier for integration. So I'm now going to find my a and my b. Just as we have done the other one, I say x plus 1 is supposed to be equal to this, whereby x divided by that you are remain with the x squared plus 1. You go to this one, x squared plus 1 divided by that you remain with the x and multiply now by bx plus c. And finally, you get this value. Now we are going to find our constants. By using the coefficient, like for example, we can use the coefficient of x, which is 1. This other one, where there is x, the coefficient is what we are looking for. We have only one, and that is c. So the c we get is equals to 1. From there now, guys, we come to the constant. In this problem, we have a constant 1. On the other side, the constant is only a. So our a also equals to 1. That is 1 is equals to a. Then we are looking for b. For b, we now come and look for the coefficient of x squared this side. We don't have any x squared, so the coefficient is supposed to be 0, as stated here. And the numbers that have x squared are a and b. And so we are able now to find, because the a we have it is 1, so b is going to be b equals to -1. Now we come with our equation here now, that is the partial fractions for that. We now come and find the integral of each. Of course, we have to put here the dx. Here we have the dx, and this one you have to put the dx. So here we now come and integrate that. You get ln x, natural logarithm of x. This one is tan inverse if you check at your table, you find that this term represents an inverse x. And then we have this one, which is natural log of x squared plus 1. Whereby because of these two, we had to add another 2 here. Because if you come and differentiate these guys, you will get 1 over x squared plus 1 multiplied by 2. So that 2 we have to eliminate it by putting these 2 here. Otherwise, we'll have made a mistake. Because when you differentiate this one, let's say you are differentiating, you'll get, let me just show you an example here. Let's say I'm differentiating this, guys. That is ln x squared plus 1. This one will be 1 all over x squared plus 1. And then differentiating in the inside, you get 2x. Now, guys, if you look at our question here, we don't have a 2 here. So we cannot have this one alone as our integrated figure from here, because here we don't have 2. If we have 2 here, guys, then this would be the answer. To compensate for that, that's why we now divide by 2 here. And so, guys, finally we come and replace our limits. That is, the limits we have, guys, here is actually, let me just put them here. We have 1, maybe I can put on this side. We have 1 and 2. So those are the limits we have now put in here. We have put 2, and then we have also put 1. And finally, working out. For this one is going to be an angle. That's why I've put it in terms of radians. The same case with this other one. So for the first one, you put 2 there. You also put the 2 there. If you come here, you put 2. 2 squared plus 1 is 5. Then that is the figure. When you come for this other one, ln 1, that is you put 1. And this one you put 1 again. And then you can put 1 here. 1 squared plus 1 is 2. So finally, this is now the figures you find, and you can work out those that are alike, and work out those that are with the pi. They will bring this, and the complete figures will bring this value. So this is how now you work out our question like that. So guys, thank you so much for listening to me. And I forget that this other problem, the last question, guys, we are supposed to do, maybe I can give you an assignment, you go and try it. It's written like this. It's written like 11 minus 3x dx all over x squared plus 2x plus minus 3, like that. Find the integral for that. And the answer, guys, I'll give you is actually here. The answer is this. That is -8 ln x plus 3 plus 5 ln x minus 1 plus c, like that. That reminds me, guys, that I might have left out the c in our first question. So guys, the question we have done, the first one, yes, this question we had left out the c. So this one will have a constant, since we don't have limit. So guys, thank you for listening to me. Bye bye.